For number 12, again, we have another right triangle, except for this time, I don't know one of my legs, okay? But the formula still works the same. I have 6 could be is A, since this side's B, and then 10 is C. So I'll plug everything in. I've got 6 squared plus B squared equals 10 squared. So 6 squared is 36, 10 squared is 100. I solve all this and I get B squared equals 64. Once I take the square root of both sides, that gets rid of that little 2. Those cancel each other out and I just have B left. So B equals the square root of 64, which is 8. So B equals 8. For number 14, notice it says your directions say determine whether the triangle with the given side lengths is a right triangle. Again, I see the key words right triangle. If you see that, this is Pythagorean theorem. Instead of solving for a letter, though, it's kind of like a question. Does a squared plus b squared really equal c squared? And so they give you your smaller two sides are always your a and your b, and your largest side is your c. So if I plug that in, I'll have 5 squared plus b squared, which is 12. 12 squared equals 14 squared. Does that really equal each other? If I put all this in my calculator, I'll get 25 plus 144 is 169, and then 14 squared is actually 196. So those do not equal each other, so that's a no. The next one works the same way. A, B, and C. Plug it into your formula. 60 squared plus 80 squared, does that really equal 100 squared? If I square both of these and square that, then add this side together, I get 10,000 equals 10,000, so that's a yes. Again, on these directions, I see a right triangle. That's again Pythagorean theorem. A squared plus b squared equals c squared. It says find the length of the third side. So you have a b, you have a c, plug everything in and just find your a. Okay? So a squared plus 9 squared is equal to 15 squared. I get 81 here. I get 225 here. If I subtract 81 from both sides, I get 144. So a squared equals 144. So I'll take the square root of that. And of course, a would be 12. For 17, same thing, except this time they give us an a and a b. So I'm going to look for c. So 10 squared plus 24 squared equals c squared. If I put all this in my calculator, I'll get 676 equals c squared. To get the c by itself, I want to take the square root of both sides, so c equals 26. If you get an extremely large number for your answer on Pythagorean theorem, you haven't taken the square root. So just make sure that it makes sense. If one side is 10 and one side is 24, the other side is not 676. Okay, so just double check yourself before you wreck yourself. And then, so 18 through 22 is what y'all did most recently. If the decimal repeats itself, it's rational. If it can be written as a fraction, it's rational. Typically square roots are irrational, but just double check it in your calculator. So I'll take the square root of 6, and that gives me a decimal that doesn't repeat and it's not short. So that's actually going to be irrational. For 21, I have the negative square root of 9 divided by 3. Well, 9 divided by 3 is 3. The square root of 3 is not perfect, so I assume it's going to be irrational, and I was correct. Okay, so that's irrational. For number 22, notice it has a square root, but it's going to be rational. Why? Because the square root of 6 is actually 6 over 2, which makes that 3. Okay, and I can again double check that in my calculator, make my fraction. I have the square root of 36 all over 2. That's going to be 3, so that's rational. Good luck tomorrow, y'all.